So many persons will get confused if they see this kind of question in their exams. It is very simple. But you are asked to find the value of P if the line that passes through these 2 points is parallel to the line that is given. Now, if the 2 lines are parallel, their gradients are always the same. Why do I say so? Remember that gradient is the same thing as slope, and the slope is the degree of steepness of a line. Now, when the 2 lines are parallel, that means their steepness, the degree of their steepness, how slopy they are the same. So in this case, since we are asked to find the value of P, we are going to find the gradient of this first line, we find the gradient of the second line, and equate the 2 gradients together. Let's start with the gradient of the first line. So we're going to divide our board into 3 equal parts because we need space to solve this question. Now, for the first one, we are given the 2 points. The point number 1 we have -1 minus P, and the second point we have minus 2P 2. To find the gradient of a line given 2 points, we use the formula n equal to y2 minus y1 all over x2 minus x1. And given our points here, this will be your x1, the first number here is your x1, this is your y1, x2, and this is your y2. So we bring out our parameters. Our x1 is equal to -1, our y1 is equal to minus p. Our x2 is equal to minus 2p, and our y2 is equal to 2. We are going to substitute these parameters into our formula for the gradient, such a way that we have your m here to be equal to y2, which is 2 here, minus y1, which is minus p. Don't always forget your minus, it is very important. So we have minus p, and that is all over x2, which is minus 2p, minus x1, which is minus 1. So your m, your gradient, is 2 here, minus minus is plus, we have p, all over, minus 2p, minus minus is plus, and we have 1. So this is the gradient for the first line. For the second line we have here, 8x plus 2y minus 17 is equal to 0. We are given the equation already. Now, recall the gradient, the equation of the straight line is equal to y equal to mx plus c. In a straight line equation, the y is always in one side of the equation. And because of that, we are going to make y the subject of formula in this equation. If we do that, 2y is in the left-hand side already, and is equal to, this 8x will go to the right-hand side because minus 8x. Minus 17 will go to the right-hand side to become plus 17. We are making y the subject of formula. So we divide both sides by 2. If we do that, 2 here will cancel 2. We now have here y to be equal to minus 8 divided by 2 is minus 4, and we have x plus 17 over 2. Now, remember, this is the equation, the general form of the equation of a straight line, and this is the equation of our line. Let's compare the two of them. Comparing the two equations, you find out that your y here is equal to your y here, mx is equal to minus 4x, and your c, which is the intercept, is equal to 17 over 2. We are looking for n. So, we are going to equate the n. mx here will now be equal to minus 4x. Next, divide both sides by x because we are looking for n. We divide both sides by n. X here will divide x here will divide x. What we now have left, our n will now be equal to minus 4. So, we have succeeded in finding the gradient for this first line to be this, and the gradient of the second line to be this. As we said in the beginning, we are going to equate their gradients because they are parallel lines. Do that, we have the first gradient here is 2 plus p all over minus 2p plus 1 equal to the second gradient, which is minus 4. We are looking for P, remember? So we are going to make P the subject of formula. So remember this minus 5 is a minus for all over 1. So we cross multiply. Where we cross multiply, 2 plus P multiplied by 1 will give us 2 plus P. And is equal to minus 4 here multiplied by minus 2P plus 1. Next, we open the bracket. When we do that, we have it to be 2 plus P and is equal to minus 4 times minus 2P. Minus minus will give us plus. 4 times 2 will give us 8. And we have P. Minus 4 times plus 1 is minus 4. Now, we collect like terms. We have P here. This 8P will come here to become minus 8P. And is equal to, we have minus 4 here. 2 will come here to become minus 2. P minus 8P is minus 7P. And is equal to minus 4 minus 2 is minus 6. We are looking for P. So we divide both sides by minus 7. When we do that, minus 7 here will cancel minus 7. What we have here is P and is equal to minus divided by minus is plus. We have left 6 over 7. So with this, we are able to find the value of P to be 6 over 7. I hope you enjoyed it. If you have any question, do ask in the comment section. So many persons don't know that we can solve simultaneous equations using matrices. Let's try it out. Now, we are given the two equations. The first thing we are going to do is to place them into matrix form. So we draw our matrix form. We have 3x here, so we have 3 minus 4y, we have minus 4. We have 7x here, so we have 7 plus 1y, we have 1. Close your matrix. In the second matrix, a 2 by 1 matrix, we have it as x and y. And this is equal to another matrix at the right hand side. 1 here, and we have 23 at this point. Now, let's say this matrix, the first 2 by 2 matrix, let's name it matrix A. And that is equal to 3, 7, minus 4, and 1. So the first thing we do is to find the inverse of this matrix A. And to find the inverse, we need to find the determinant. So let's find the determinant of A. Determinant A is going to give us 3 times 1, which is 3, minus 7 times minus 4 is minus 28. And this is equal to 3. Minus minus is plus 28. And that is equal to 31. If the determinant is equal to 31, the inverse is equal to, that means the inverse of A inverse is equal to 1 all over the determinant, 31. Then we'll write the leading matrix A. But in this case, the leading diagonal 3 and 1, we are going to exchange them. In place of 3, we write 1, and in place of 1, we write 3. So we have here as 1, and we have here as 3. Then we multiply the elements in the other diagonal by minus 1. Minus 1 times 7 will give us minus 7. Minus 1 times minus 4 will give us 4. So this is the inverse of this leading matrix. What we are going to do now is to multiply that inverse by both sides of the equation in this matrix. Take note, when multiplying, write the inverse first, because in matrices, A times B is not equal to B times A. So if you write this matrix before the inverse, you are going to get the wrong answer. You write this inverse before you write the matrix. So what we have here is this inverse, 1 over 31, bracket is 1, 4, minus 7, 3. Multiply by, we have 3, minus 4, 7, and 1. And we have x, y, equal to, in the right hand side, we are still going to do the same thing. We are going to write the inverse before we write this matrix. So the inverse is 1 all over 31, matrix 1, 4, minus 7, 3. We are multiplying it by 123. So, follow me for the multiplication of matrices. We still have here, this is a scalar 1/31 and is equal to, we pick this one, multiply by 3. 1 times 3 is 3, so we have 3 plus 4 times 7 is 20, is 28. 28. This same one multiplied by minus 4, and that will give us minus 4. 4 times 1 will give us plus 4. The same thing here, minus 7 times 3 will give us minus 21, and 3 times 7 will give us plus 21. Minus 7 times minus 4 will give us 28. 3 times 1 will give us plus 3. We close it. And is equal to, in the right hand, okay, sorry, we have our x, y is equal to, in the right hand side, we are still multiplying out. Remember, this is 1 all over 3 all over 31. Then our matrix 4. 1 times 1 will give us 1. 4 times 23 will give us plus 92. Minus 7 times 1 will give us minus 7. 3 times 23 is going to give us 69. So we have plus 69. And we close it. Next, here we have 1 all over 31. 3 plus 28 is 31. Minus 4 plus 4, 0. Minus 21 plus 21, 0. 28 plus 3, 31. We close it. And we have x and y, which is equal to this 1 over 31. 1 plus 92, 93. Minus 7 plus 69 will give us 62. Now, this is a scalar, so we can divide that. When we divide that, we have now 31 divided by 31 is 1. 0 divided by 31 is 0. 0 divided by 31, 0. 31 divided by 31, 1. I will have x, y. This is equal to, also in matrix, 93 divided by 31, 3. 62 divided by 31, 2. So, at the right hand side, we have an identity matrix. When you have a matrix like this, called an identity matrix, and it's equal to 1. When you multiply this matrix by this one, it's going to give us x, y. Because 1 times x, y, multiply any number by 1, it gives you that same number. And this identity matrix is equivalent to 1. So we have x, y, and this is equal to 3, 2. Now, in comparison, when you compare the left hand side to the right hand side, we have that x is equal to 3, while y is equal to 2. Those are the solution of that simultaneous equation. If you apply your elimination method, you are still going to get the same 3 and 2. If you apply a substitution method, you are still going to get the same x equal to 3 and y equal to 2. If you have any question, feel free to ask in the comment section. Also, like my video, follow me, share it to your friends and loved ones that may benefit from it, and comment. Thank you for watching.